back. In 2.2, you get to play with infinite limits. And limits at infinity. So we'll start with the limit of a polynomial function at infinity. So let's let p of x be some polynomial function. We'll call it 7x squared minus 8x plus 19. Take a look at the limit as x approaches infinity. And really, this is going to depend on what's going on with our leading term. So this is the limit as x approaches infinity of, I'm going to go ahead and multiply by 1, sort of in a different way than we usually do, but it's still multiplying by 1. So I'm taking the limit as x goes to infinity, and I've multiplied top and bottom by 7x squared. So this is the limit as x goes to infinity of p of x. So limit as x goes to infinity. And a little bit of simplifying. We have 1 minus 8 over 7x plus 19 over 7x squared by 7x squared. Well, as we've seen before, if your numerator is constant, your denominator grows without bounds and absolute value. That term will approach 0. So we have 1 minus 0 plus 0 is 1. 1 times 7x squared is 7x squared. So this limit as x goes to infinity of function p of x is really just the limit as x goes to infinity of the leading term, in this case the 7x squared, which would be infinity. Similarly, the limit as x goes to negative infinity, again, that would just follow what happens with the leading term. So the limit as x goes to negative infinity of 7x squared. Negative squared is positive. Positive by positive is a positive. This will also approach positive infinity. So see if you can kind of recreate what we did there of the multiplying by 1 idea on, let's say p of x is 5x to the 5th minus 2x to the 4th minus 7x plus 1. So see if you can find the limit as we approach infinity and the limit as we approach negative infinity. Okay, welcome back. So limit as, we'll do just the infinity first and then apply it to the negative infinity. So limit as x approaches infinity, and again we'll just multiply by 1. So 5x to the 5th over 5x to the 5th minus 2x to the 4th over 5x to the 5th minus 7x over 5x to the 5th plus 1 over 5x to the 5th times 5x to the 5th. So that way we've multiplied top and bottom by 5x to the 5th. So the limit as x approaches infinity of function p of x is the limit as x approaches infinity of 1 minus 2 over 5x minus 7 over 5x to the 4th plus the reciprocal of 5x to the 5th by 5x to the fifth. But as x is growing without bounds, 2 over 5x goes to 0, 7 over 5x to the fourth goes to 0, 1 over 5x to the fifth also go to 0. So then this limit as x goes to infinity of function p of x is just the limit as x goes to infinity of the lead 5x to the fifth, which would be infinity. The limit as x goes to negative infinity, however, for function p of x, limit as x goes to negative infinity of 5x to the fifth. Odd number of negatives, it'll stay negative, and a negative by a negative is a negative by a positive is a negative. So this would be negative infinity. So that's playing with polynomials. We also get to play with rational functions and limits. And specifically, we'll take a look at horizontal asymptotes. So let's consider r of x is 7x cubed plus x squared plus 2x plus 1 all over 5x cubed plus 2x plus 7. So if I want the limit as x goes to infinity, the function r of x, and that's what will tell me if I do or don't have horizontal asymptotes. We'll look at infinity as well as negative infinity would kind of do a similar thing. Again, we're going to use the multiplication by 1 kind of thing. So the limit as x approaches infinity of 7x cubed over x cubed plus x squared over x cubed plus 2x over x cubed plus 1 over x cubed. So we multiply the top by 1 over x cubed. We'll also multiply the bottom by 1 over x cubed. How I picked that out, that was the highest exponent that I saw anywhere in the problem. As x goes to infinity, let's do a little simplifying here. We have the limit as x goes to infinity of 7 plus 1 over x plus 2 over x squared plus 1 over x cubed. So we're just doing any simplifying that we can do. Same thing in the denominator. We have 5 plus 2 over x squared plus 7 over x cubed. Any of these that have a constant at the top, variable at the bottom, and x is growing without bound will drop to 0. So all of those terms drop to 0, and we get 7/5. So y equals 7/5 is a horizontal asymptote. 7/5 by itself is not a horizontal asymptote. You do need both sides to your equation. All right, so next up we'll look at g of x is 18x squared minus 7x plus 9 over 5x cubed minus 4x squared plus 1. Again, if I'm looking for horizontal asymptotes using limits, I want the limit as x goes to infinity. So the limit as x goes to infinity, and here x cubed is the biggest of our variable exponents. We have a third power, so 18x squared over x cubed minus 7x over x cubed plus 9 over x cubed all over 5x cubed over x cubed minus 4x squared over x cubed, etc. So limit as x goes to infinity of g of x. So limit as x goes to infinity of, a little simplifying, we have 18 over x minus 7 over x squared plus 9 over x cubed. And downstairs we have 5 minus 4 over x plus 1 over x cubed. Any of these where the version of the fraction is constant over variable and the variable is growing without bounds will go to 0. So we have all zeros upstairs and a 5 downstairs. 0 over 5 is 0. So y equals 0 is our horizontal asymptote. Centered, there we go. Okay, so give those two a try. See if you can use limits to find any horizontal asymptotes. Okay, welcome back. So if we're just interested in horizontal asymptotes, we'll do the limit as x approaches infinity for function, in this first case, f of x. So limit as x approaches infinity, we'll multiply by 1 over x to the 7th, top and bottom. So x to the 7th over x to the 7th, 4x squared over x to the 7th, minus 2x over x to the 7th. Downstairs, same thing happening. 5x to the 7th over x to the 7th, plus 3x cubed over x to the 7th, plus the reciprocal of x to the 7th. So limit as x goes to infinity of function f of x. It's the limit as x goes to infinity of 1 plus 4 over x to the 5th, minus 2 over x to the 6th. Downstairs, 5 plus 3 over x to the 4th, plus 1 over x to the 7th. Any of these that have constant over variable and the variable growing without bound will drop to 0. So we have a 1/5. So limit x approaches infinity of f of x equals 1/5. So y equals 1/5 is our horizontal asymptote. G of x, everybody gets divided by x cubed. So limit as x approaches infinity of g of x is the limit as x approaches infinity of x cubed over x cubed plus 4x squared over x cubed minus 2x over x cubed plus the reciprocal of x cubed, and do the same thing downstairs. So that is the limit as x goes to infinity of 1 plus 4 over x minus 2 over x squared plus 1 over x cubed, all over 1 over x squared plus 7 over x cubed. The problem with this is that we get the form of 1 over 0. That is infinity. So we have no horizontal asymptote for g of x. Now, as far as finding vertical asymptotes, and wholes. We can also use limits for this. Let's look at f of x is x squared plus 3x plus 2 all over x squared plus 7x plus 10. So we know how to find the horizontal asymptote for that. We let x go to infinity and find out what happens. As far as wholes and vertical asymptotes, that's where we need to factor. So I want f of x, we'll go to limits in a moment, is equal to factoring upstairs x plus 2 by x plus 1, factoring downstairs x plus 2 by x plus 5. So our limit, and we approach each zero of the denominator. So we'll approach negative 2. Function f of x, so that's the limit as x approaches negative 2 of x plus 2 by x plus 1 over x plus 2 by x plus 5. So that's the limit as x approaches negative 2 of x plus 1 over x plus 5. So since we're just approaching negative 2, not reaching it, we can consider those as dropping when we're doing the limits. So negative 2 plus 1 is negative 1 upstairs. Negative 2 plus 5 is 3 downstairs. So we get close to a constant value as we're approaching negative 2. So that would make that one a whole. We can't reach the negative 2 because that would force us to divide by 0. So this one is a whole at negative 2, negative 1/3. Approaching our other 0 of the denominator, limit as x approaches negative 5. So limit as x approaches negative 5. And I'll go ahead and go with the simplified version of it, x plus 1 over x plus 5. We get a negative 4 over 0, so that is negative infinity. So if we approach infinity or negative infinity, that would make it a vertical asymptote as opposed to approaching a constant, which would make it a whole. So we have a vertical asymptote of x equals negative 5, so the location where that infinite limit was reached. Okay, so let me have you all try one that has it all. So your function will be f of x is upstairs x squared plus 4x minus 21, downstairs 2x squared plus 15x plus 7. So go ahead and find any horizontal, vertical, and wholes. Okay, welcome back. So we'll look for the horizontal first. X squared is the biggest of each of the polynomials top and bottom. So we'll do the limit as x approaches infinity of f of x. So that's the limit x approaches infinity of x squared over x squared. 4x over x squared minus 21 over x squared, and do the same thing to the bottom. So that's the limit as x goes to infinity of 1 plus 4 over x minus 21 over x squared. Downstairs 2 plus 15 over x plus 7 over x squared. Those 4 at the back are going to 0 because we have a constant no matter how big. over a variable that's going to grow without bound. So that will reach 1/2. So that is a horizontal asymptote of y equals 1/2. Make sure you have both sides of your equation for the horizontal asymptote. Vertical and oblique, we want to look at the factored version first. So upstairs, let's see, we're multiplying to -21, adding to a +4, so a +7 and a -3 will do the job nicely there. Downstairs, let's see, a 2x and an x. We want to multiply to 14 and add to 15. So 14 and a 1, so 7 and a 1, plus and a plus. So we want to approach each of the zeros of the denominator. So we'll do the limit as x approaches -1/2. That would make that first factor into a 0 of f of x. So that's the limit as x approaches -1/2 of, I'll go with the reduced version of x minus 3 over 2x plus 1. So that is a negative, happens to be -3.5 divided by 0. So that is a -infinity. So we grew or fell without bound. In this case, fell without bound. So this is a vertical asymptote of x equals -1/2. Again, make sure you have both sides of your equation. Then we'll approach the other 0 of the denominator, -7. So the limit as x approaches -7 of x minus 3 over 2x plus 1. So we have a -10 up top, and let's see, -14 plus 1, -13, so 10/13. So then we have a whole, since we approached a constant, a whole at -7 for the x, 10/13 for the y. Okay, so as far as problems to try out in 2.2, and you're going to want to use these limit methods. You may have seen them other ways in other classes. Calculus relies heavily on limits, and this is letting us practice the limits, so use the limit method. 1 to 31 on the odds, 41 to 71 on the odds as well. If you have any questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.